MPLS TE cost calculation. In this video, I'm going to talk about the detail of cost calculation in MPLS traffic engineering. This is a conceptual video and it's so important to better understanding of the cost calculation process in MPLS traffic engineering, because when we know the cost calculation method in MPLS traffic engineering, we can better understand the behavior of the tunnels, and in some complex scenarios we can find the problems about the traffic engineering and we can solve them, and this is so useful. Don't forget, we have two kind of engineers. First, technicians, and the technicians only can configure and only can do the basic tasks. And after that, professional engineers, that engineers can configure and also can understand the details, the concepts of a tool. Because of that, in complex scenarios, the for example, professional engineers can find the problem, can solve the problem, and this is so valuable. Okay, in this video I'm going to talk about the detail of cost calculation in four scenarios: scenario 1, scenario 2, scenario 3, and scenario 4. These four scenarios are using the same topology, but as you know, here we have different tunnels. Okay, I will talk about all of this condition in this video, and because here we are using the same topology, we need only to configure one of the for example, scenario 1. After that, we can copy that scenario 1's configuration and only doing some change about the addressing. Okay, because of that, we can configure the scenario easily, and we will not have any problem about the faster configuration of this scenario. Okay, let me to start with the first scenario, the scenario 1. In this scenario also, I'm going to talk about two important concepts in the traffic engineering or MPLS traffic engineering beside of the cost calculation. The first is the equal cost load balancing or equal cost load sharing. Let me to write here equal then cost load, for example, sharing. You will understand the detail of equal cost load sharing in MPLS traffic engineering. And also the next topic is unequal cost load sharing. Maybe in some books you see the equal cost multipass, okay, or equal cost load sharing, and also unequal cost load balancing, UCLB, or unequal cost load sharing. All of them are same. Okay, let me to talk about this scenario, the scenario 1. Don't forget that after talking about the scenario, after understanding the detail of the scenario, we can implement the scenario, and this is so useful to better for example, experiencing the result. Here, as you can see, we have a network R1, R2, R3, R4, and R5. I configured one interface tunnel from the router 1 to router 5. For example, you can configure these T tunnels because you learned about the configuration of the T tunnel in this course. Here, we don't have any problem. And now I'm going to talk about the detail of about the cost calculation, and also in some cases equal cost load sharing, and in other cases unequal cost load sharing. First, starting from this scenario, you know that in scenario 1, this is the scenario 1. Okay, in scenario 1, when we are configuring a tunnel from the router 1 to the router 3, assume that I am configuring this tunnel with the explicit path from R1 to R3, then R5. Okay, this is our tunnel. Okay, how we can configure, how we can for example, calculate the cost. The cost of a tunnel, a TE tunnel, is the lowest cost of the IGP between the R1 to R5. As you can see here, we have two paths. Also, let me to say that in this video, I'm going to use the OSPF. You can configure ISIs. Both of them are same, but I'm going to use the OSPF as only one example. Okay. Also, let me to say that in OSPF, we have the cost of 1 for the interface fast Ethernet, because cost of interface equal to the 10 to the power of 8 divide to a bandwidth of the interface, because the bandwidth of the fast Ethernet bandwidth is 100 megabit per second. Okay, the cost of a fast Ethernet interface in OSPF equal to 1. Because of that, when I am calculating the cost, I can say that from R1 to R3 we have the cost 1. Okay, so easy. After that, as you know, okay, here between the R1 to R5 we have two paths. Okay, because the tunnel started from R1 to R5. The first pass is passing from the R3 and the R5, and the cost of this pass is 2. Because of that, the cost of this T tunnel, okay, or the metric of this T tunnel is equal to the 2. Okay. Also, we have another pass from the R1, R2, R4, R3 and R5. The cost of this pass is higher than the cost of the R1, R3 and R5. Because of that, we can say that the cost of the T tunnel is 2. Okay, this is the first, for example, things that we should know. After that, let me to talk about the load sharing. What is the load sharing? Look at here. Here you can see that in the router 5, okay, assume that in router 5 we have one address, loopback 0, okay, loopback 0 or loopback 1, quad 5/32. The first question is that when we are using the T tunnel, okay, and also we have IGP pass from the R1 to R5 loopback, which one is better and which pass is used? Let me to talk about that. Look at here. If you want to calculate the cost from the TE tunnel, okay, to the quad 5, we have the cost of TE tunnel equal to 2. Okay, this is the cost of TE tunnel. Let me to write TE cost. And then the interface loopback 1 cost, I'm going to write loopback 1 cost. The loopback cost in OSPF is 1, okay, equal to 1, and the T cost, as I mentioned before, is 2. Because of that, totally we have the cost of 2 plus 1, and then the result is 3. Okay, this is the cost of the T tunnel. Also, we have another, for example, pass, the IGP pass. You know that the quad 5, okay, /32 now is learned from the TE tunnel, okay, is learned from the TE tunnel and also from the IGP. Because of that, above the IGP, if we want to calculate, we have the cost of 3 link, the link R1, okay, to R3, R1 to R3 cost, okay, R1 to R3 cost, plus R3 to R5 cost, R3 to R5 for example, cost, and after that the loopback 1 cost. Okay, let me to calculate this cost. You know that the result of this cost is 1 plus 1 plus 1 and then equal to 3. As you can see here, we have two paths with the same metric. Okay, first is the T tunnel pass, and the second from the for example IGP cost. And don't forget that this IP address, the quad 5, is residing on the end point of the tunnel on the router 5. Okay, here we have a question, and the question is, do we do load balancing between the T and IGP, okay, when we have the same metric to a for example destination in the for example the TE tunnel tail? You know that here the R5 is the tunnel tail, and also the R1 is the tunnel head end of tunnel, and here we have tail end of tunnel. Okay, the question is that, do we do the equal cost load sharing between the TE tunnel and the IGP? The answer is that when we have two pass, the first is a tunnel pass and the second is IGP pass, to one destination on the for example tunnel end router, we are using only the TE tunnel. This is the first rule about the equal cost load sharing. Let me to say that in equal cost load sharing, when we have a tunnel and also one IGP pass, and both of them are using the metric, for example M1, the M1 metric is 3, equal to 3 in this example. Okay, same metric, we are using the and this for example tunnel and IGP calculate this metric for a tunnel, for a destination on the tunnel tail. Okay, we are using only the tunnel pass, the T tunnel, okay? Tunnel pass. I